Good morning, audience. I'm Chayn Sun. Along with me, my two PhD students, also they are the research associate for this project, Ryan Turner and Wenhui Cai. So I'm going to show very briefly what we are doing. So in response to Ben's very fancy digital twin, my team will build the data to fit into the digital twin. So if you keep going, so we're trying to build this semantic 3D urban mapping for regenerative communities. Is Chris here? Wow.
Yes, he's over there.
Yeah. So hey, Chris. So for this project, we're trying to focus on sports facilities. We're looking at sports facilities as social infrastructure to bring people together to understand how sports facilities impacted by climate change, by environmental change, and how inequality distributed across neighborhood. We're going to bring data together, build a model to understand the problem and provide the solutions. Quickly go to the next one because we have more slides. So I will talk about the framework, and Wenhui will talk about the two key data sets we generated, and Ryan will showcase the preliminary digital twin. And if I have time, I'll talk about how we're going to propose solve your three priority areas together into one digital twin. Okay, thank you. So on the RUDY node, my small team, we're trying to build this semantic digital twin for analyzing climate resilience, exposure, and inequity for sports facilities, that including the sports oval, or sports swimming pool, all the terms we can identify as sports facilities in neighborhoods. So this is our framework, currently working on connecting data to understand the risk, understand the community need, and using spatial analysis to understand the opportunity, the association between the risk and the community need. Okay, moving to the next one. So by mid-May, and we're working on pretty much half year. We generated a couple of data sets with one, the model, the PM 2.5, already delivered to AURIN, and Wenhui is going to talk about this very new, very innovative data set called compounding heat air quality effect data. And we have a list of publications. Next one. Okay, move on to Wenhui to talk about this new dataset, PM 2.5 modeled result and the.
Thank you, Chayn. So I just go quickly. So we have done the first one is fine scale the PM 2.5 at 100 meters. So it's used a model called land use regression model. So it's from moving from the site-based monitoring, air quality monitoring, to a surface, which we can use for modeling the specific time areas and time period and the specific areas like the Greater Melbourne areas. And you can see the lower line is the HW standard, which 5 micrograms per cubic meters, and the higher red line is the Australian standard. And we also do a population-weighted calculation to understand where is the PM 2.5 burden for population tailored. And so, population experience exposure, multi-exposures simultaneously. So this leads to our concept of the heat and air compounding effects definition. So here we're actually using the 10 years satellite imagery to calculate this extreme events. We use 3 days moving windows to understand the extreme of the heat and AOD, which is the proximity of the air quality. And we combine them each other together to calculate the compound extreme event. And we also here to include both the frequency and the intensity of the events. So this is the heat air compound frequency and intensity. We can see there's mainly two centers here, which is the western and also the southeastern areas. Yeah. So next, we'll just move to Ryan.
Yeah, so just like a conceptual framework of a digital twin, it's kind of this information feedback loop between physical space and the virtual space, integrating static data sets and live sensors to kind of bring information back to reality, perform informed decision making, and then update the digital twin based on that. So we have integrated those data sets that Wenhui just demonstrated into like a demonstration application. You can scan the QR code here if you'd like to have a quick look. But this is an example of kind of how we can investigate these data sets more to see how the air intensity, heat and frequency, and then the compounding aspects of these two interact with the built environment. We can look at 3D buildings and then investigate further how these sport facilities can kind of be social infrastructure and investigate the differences between different parts of the city. So that's just a quick demonstration of, like a visualization. So
fantastic. Thanks very much. I think that's time is up now.
Yep.
Okay, just final slides. Yeah, so in the next month, we're going to integrate AI and analytical layer to the digital twin, bring all the data together, and then we can identify the sports facilities served area which they are exposed to more climate risk, and how we can mitigate the problem and reduce the inequality around Victoria. And final one. This one I propose in responding to the 3 priority area we propose in next year. Our team, our RUDY, to bring everything together to deal with the housing problem, the mobility system, the network analysis, as well as energy system to meet the net zero. We're going to create net positive community to achieve regenerative community. That's our goal. Thank you.
Fantastic.
Okay.